All right, so kind of this part two video here. So in the first one, we talked about catastrophism and catastrophic events that led to mass extinctions. Extinction is a normal process. It's part of that theory of uniformitarianism. Extinction is always occurring. There's always organisms that um, don't have the adaptations to survive in their environment, or they have mutations that make it less favorable, and it just has this cascading event. So there's natural extinction that occurs among species. However, when you have a large number of species die off at the same time, usually like 20% or more, then that means that you're probably having a mass extinction event. There's those five major ones where we have 50% or more of all species die off. Not individual organisms. We're talking about species, entire like humans and dogs and cats. You know, the entire species being killed, not just half the organisms of cats. We're talking about all cats. So those are mass extinction events. Well, there's just like I said, there's normal extinction that occurs among species, and this happens because of gradualism. So gradualism is this idea that there are gradual changes being made to the Earth's surface constantly. And that is because our plate tectonics. So as those plates move, they cause the land to change. For example, if we live in the ocean and all of a sudden there's a mid-ocean collision of these plates and they start building a mountain range, that means that those organisms that lived in that spot are not going to be able to survive on land. They're going to die, or they're going to move away, or they're going to adapt. Not that they choose to adapt, but there's going to be some kind of mutation that makes it more favorable, and then another mutation, and eventually so that they can survive in their new environment. But as these mountains form, it changes the biosphere in that area, because let's face it, there's not marine creatures that live on the top of mountains. And vice versa. Sometimes you'll have organisms that live in higher elevations, but as those elevations drop due to erosion and they get lower and lower, then the environment changes. Because high altitude, you're talking about usually less rainfall and colder temperatures, whereas once you get lower in elevation, then oftentimes you have more rainfall and warmer temperatures. And not everything is adapted to survive in those environments. And so these slow processes, though, occur over millions and millions and millions of years. What usually happens in those cases is that the organisms that live in that area either go to a new, different habitat that is currently like the one that they live in, or there's phenotype changes within them that allow them to continue to survive in that environment. A good example of this is horses that we've talked about before. So horses were once very small, almost dog-like creatures. They had 3 fingers, or maybe even 4, and on their feet, and they were small, and they lived in a forested area. And the way that we know this is because we have the fossils of the organisms themselves. We have fossils that exist in that same rock layer that indicate that there was forest ecosystems. So there was other forest-type animals that lived there, and there was, of course, the plant life that we had some kind of fossil record of. So maybe ferns, tree trunks, leaf imprints that would indicate that this was a wet forest environment. Well, as the environment changed, rather due to the plate shifting to a different location where it got less water, if it rose up, whatever caused the changes, eventually that forest was dying off. But it took a really, really long time for that to happen. And so the horses, they would have these mutations that would occur that were just random, but that random mutation made it just that much more likely that that one organism would survive to reproduce, and then its babies would reproduce, and then eventually you had multiple generations that had found that this mutation was beneficial, and nature selected it to be beneficial basically, and allowed that organism to continue to grow and expand basically. And then it just kept on happening that way, where you had a mutation that would occur that would change the organism just slightly, but that mutation was a favorable mutation because nature said, hey, you're surviving, whether it because you didn't get eaten by a predator, you had something that helped you survive a predator, or you were able to access new food sources. It allowed that organism to survive, and then because it survived, it was able to reproduce. And then eventually the entire species gained that because it's the ones that didn't have that mutation, they started dying off because it was no longer favorable to be the way that they were. And so if we look at the fossil record of horses, we see that they got larger and larger and taller, and they went from 4 fingers to just basically 1 hoof. And that took millions and millions of years. In fact, I don't know the exact time frame of that fossil record, but let's say it's 30 million years. So over the time frame that the forest was becoming more grasslands, the horse slowly was able to adapt with it, not because it chose to adapt, but because of those random mutations that became favorable. And so we have the fossil record that shows that. So geological processes are continuing today. That's the reason why we have earthquakes. It's the reason why we have tsunamis, is that we have these changes as these plates are shifting. It's continuing to change the environment. If you look at the Appalachian Mountains kind of look like these rolling hills like this, and it's beautiful and it's covered in green and all that stuff. If you go out to the Rocky Mountains, you have mountains that look more like this, right? You have these tall peaks, and they are truly rocky. You don't have like these gentle hills. You have rocky peaks that have rocks on the top of them, and they look very sharp, and they're very defined mountains. That's because the processes that are making the mountains out west are very active, and they're still pushing up against each other and causing that uplift, whereas what caused the Appalachian Mountains is basically stop moving, or at least stop colliding at that point, and instead there's been a shift in those plate tectonics where there's no longer that collision causing those mountains. Well, those mountains, the Appalachian Mountains, used to look like this. They used to look like the Rockies, and they were much taller. But through the process of erosion, so as rain would fall on it, as wind would hit it, it eroded these mountains, and they basically become these level, much more level mountains. And all the sediment that was here, that was this part of the mountain right up here, the cone shape, whatever, as it got eroded, it was washed down into basins to create new layers of sedimentary rock. So sedimentary rock is constantly being formed through these gradual processes. So we have plate tectonics that are occurring that are changing the environment, and then we have erosion that's also changing these environments. As the mountains get eroded, they get shorter, and all that is moved and creates new sedimentary rock layers. Because the process of making sedimentary rock is basically erosion and then deposition. So mountains are eroded or land's eroded, and then it's deposited into a new area wherever the water takes it. If you were to look in Louisiana, where the Mississippi River is, it looks really, the state of Louisiana, you have like this long part out in the state of Louisiana, and that's where the Mississippi River has literally been depositing new sediments, and it continues to grow. Now there's sea level rising occurring that's starting to take some of that stuff out, but it continues to deposit more and more sediments, creating more and more land out there. And most of that's being driven by stuff in the Appalachian Mountains and the Great Lakes region as it's being washed down into that area, and some from the Rocky Mountains as well. And so there's these changes that are constantly occurring. That's gradualism. And the biggest difference between catastrophism and gradualism is the impact that it has on the biosphere. Catastrophism causes mass extinction events. It causes a large amount of life to die out in a very short amount of time, because unless you are already adapted to the environment that's created by that catastrophic event, you don't have time to adapt. The organism cannot change quickly enough to be able to survive that event. If Memphis were to, over the next million years, become flooded, raccoons wouldn't just all of a sudden be able to develop gills that allow them to survive that environment. They would either move or become extinct. So that's catastrophism. Gradualism, on the other hand, takes millions upon millions of years, and it allows a chance for mutation to occur and favorable phenotypes to be selected and passed down, and eventually it leads to the evolution of a species to survive in that changing environment. So natural selection is very much a big part of this gradualism that occurs on Earth today. Catastrophism was also very much natural selection, but it's not what we consider the norm, because they are events that only happen very rarely, whereas gradualism was constantly occurring. And there will be catastrophic events in the future. Maybe it'll be another meteor, maybe it'll be another flood basalt event, who knows? But according to uniformitarianism, things that have happened in the past are happening today and will happen in the future. All right, thank you.